Okay, and welcome to another video. Following on from last time, I was talking about electricity and a little bit about resistors. This time we're going to be looking at Ohm's Law. So Ohm's Law is all to do with voltages, current and resistance. Everything in the circuit will always have the same current. Voltages, as we know, always add up to the supply voltage. And so we're just basically going to look at this for resistance. Now in this video I'll also be showing you how to calculate the correct resistance for an LED. I'll be showing you how resistance affects LEDs, and we'll also have a little circuit building session on a visual circuit. Okay, so Ohm's Law then, O-H-M'-S-L-A-W. Ohm's Law. Now Ohm's Law takes voltage, current and resistance into account. You might think it's a bit strange that I've written current as an I. In the old days they used to measure current as inductance, or the ability to create a magnetic field, so that's why we still have an I. And like conventional current, it changed after a while, so nobody bothered to correct it. And this goes into a nice little triangle here. Okay, like a T virus. Anyway. So these are all related to each other. What we need to do is we're going to be looking at creating the correct resistance for an LED. And so what we have there is the resistance that we need is equal to voltage over current. So that's what we're going to be looking at. So you can see there, resistance is equal to voltage over current. We could be looking for the current, in which case we'll then be looking for voltage over resistance, like that. Or we could be looking for the voltage. The voltage one changes slightly, so voltage would be equal to current times resistance. Okay, so when you know when you know at least two of them, you can always find the other one out. It's like a right-angled triangle. The square of the hypotenuse is equal to the sum of the squares of the remaining two sides, and all that jazz. Anyway, so the reason why I've drawn it in a triangle here is, for example, resistance is equal to voltage over current. So if I cover up the resistance, so we want to know the resistance, I'm pointing at it, so that leaves voltage over current. Same here, if I want to find out the current, I just point to it and cover it over, voltage over resistance. And if I do the voltage, then it's current times resistance. So I, and then we've got that T there, so I times R. That's one way to remember Ohm's Law. It's quite simple to do. Okay, so I have a little breadboard circuit here. It's not a complete circuit, obviously. You can see the LED is just connected to the positive power rail here of our little power supply, and we're going to connect it to the negative rail using a resistor. The first resistor I have is this one here. If you remember your resistor color codes, you'll be able to see if I have it the right way around here. This is a 1 million ohm resistor, or a 1 meg ohm resistor. So let's just stick that into the circuit here to connect it to the negative rail. And I'm going to power on the circuit. And you can see, well, you can't really see anything because that LED is very, I don't know if you can see it, very faintly glowing. I mean, very, very faintly, nowhere near as bright as it could possibly be. So that's that. Okay, let's change this to a different resistor then. So this is going to be a, I believe this is a 1K resistor. So 1000 ohms, let's turn that on. And you can actually see the LED glowing, which is nice. And we're going to bring this down even further to a 100 ohm resistor. So let's stick this in here, 100 ohms, and we should see that this glows even brighter. There we go. So that is the brightest that LED is going to glow. Wonderful. And earlier on I connected a LED to the negative and positive directly, and this is what happens if you do that. Did you see that? You can probably see a little bit more close up. Now that LED, oh, it smells of burning in here now. Okay, so I have the circuit built here, and let's just run that. You can see here the green dots here represent the current flowing through it, and it's showing conventional current, obviously. Otherwise it would be flowing the other way for actual electron current. So it shows here lots of different things. You can see that the green is the current and the purple is the voltage. So we have our 5-volt power supply here, connected to ground and going through back into ground. So that's what completes the circuit. It may not look like a conventional circuit diagram, but that's just the way this software works. So we have 5 volts here. This is designed to take 3.2 volts, which is what our LED is on the breadboard. And so if we add a 1 mega ohm resistor, you can see we've got 3.26 microamps. Now remember, our LED here is supposed to be running at 20 milliamps. That's what the specification says. So 1 mega ohm is far too much to limit that resistance. So let's just take out that, or we can change it actually. Let's stop the simulation for a second. And we're going to change this from 1 mega ohm to this. I think the second one was 1 kilo ohm, wasn't it? 1 kilo ohm. So let's just bring this down to 1, nope, not 10k, 1k. Lovely. And let's run that simulation again. Now if you notice, the current is running a bit faster there. We're still getting 5 volts, we're getting 2.17, and we're getting 2.17 milliamps through the circuit. Okay, it's still not quite enough to light up our LED. Okay, pause it one more, and let's go back to that 100 ohm resistor. Now this is where the difference should be. We go back to 100 ohms and run that simulation again, and there we go. It's nice and bright even on there. So we've got 5 volts running through here, 18.2 milliamps going through here, and 1.82 volts going across the resistor. But you notice everything here is the same current. So 100 ohms seems to be the best for that LED. So how do we actually work that out without running through a lot of simulations? Let's go back over to the camera, and I'm going to do this calculation on paper. So the part of Ohm's law we need to figure out which resistor we're going to need is R equals V over I. So resistance is equal to voltage over current. Now the voltage here, the voltage here is not the 3.2 volts that the LED needs. It's not the 5-volt current, it's the difference. So when you get an LED, it will tell you that there is a drop voltage or a voltage drop across it of 3.2 volts or 2 volts. It depends on which LED you get. So what you need to do is calculate what the difference is. So we're using a 5-volt power supply, and our voltage drop across our LED is 3.2 volts. Okay, so that over current. Now the current that we're going, oh, I just banged the camera, sorry about that. Now the current that we're actually going to be looking at is the current draw of the LED, and the current draw is 20 milliamps. Okay, so to find the resistance, we need to take that into consideration. Now the problem here is we've got milliamps as the current draw of our LED, but this is always measured in amps, whole amps. Okay, so voltage is measured in volts, but this is always measured in amps, not milliamps, not microamps. So this is whole amps. So 20 milliamps isn't 20 amps, it's 0.02 amps. So that's what 20 milliamps is. So our actual thing is going to be 5.5 minus 3.2, so that's going to be 1.8 volts over 0.02 amps. Okay, so that's what our resistance is going to be, and that's very easy to work out. So let's just take another piece of paper. So we know it's 1.8 over 0.02, so 1.8 over 0.02, and the way that we can do division on decimals is quite simple. We just move this decimal place along until we end up with whole numbers. So it's not 1.8 over 0.02, we can do 18 over 0.2 just by shifting the decimal place one spot over. But then again, this is still a decimal, so let's just shift that along one more. So 180 over 2. There we go, 180 over 2. So we know what the answer is. So our resistor that we need is going to be 90 ohms. 180 divided by 2 is 90. So that's what the resistor is. The closest one that I've got, always go one above it, never ever go below, because otherwise you're going to blow your LED. So the closest I've got is 100 ohms. So that's why when I put the 100 ohms in there, it shone nice and brightly. Okay, so let me just grab that 100 ohm resistor again, pop that in there like so, and that is the brightest that LED will glow. Marvelous. Okay, so that's a very simple, quick introduction to Ohm's law. So now you know how to get your LED nice and bright in a circuit when you've got 5 volts and you know the details about your LED. Thank you very much for watching this video. If you liked it, please hit the thumbs up. If you subscribe to the channel, it really helps us out, so don't forget to do that and hit the little alarm bell icon so you get notified every time we upload a new video. If you'd like to leave us a tip, there's a link in the description for our PayPal Me. There's also a link for our Patreon if you wanted to provide regular help to keep us in parts and bring you new stuff. But otherwise, just keep watching the channel, and thank you very much for watching this video. Until the next time, until the next video, catch you later. Bye bye. Off, on, off, on, off, on, off, on, off, on, off.